Now, let us say there is a set A and set B, and the Cartesian product A cross B will have pairs of elements of A1, B1, A2, B2 up to AN, BN. And it will have, in detail, it will be discussed in the sets and functions and relations. I will be giving a brief only about functions now. It implies there are 2 to the power of mn. Let us say it is am and it is bn. It has the cardinality of A is equal to m, the cardinality of B is equal to n. These are the number of elements in A cross B. The number of functions in A cross B will be q to the power of p, because it is A cross B. A has, sorry, it is not q, I have written as it was in the, it is n cross m, n to the power of m. This has got m elements, this has got n elements. And the total number of elements will be n to the power of m. In this, the function will be defined as a regular definition of a function every element of A has an element in B as an image of it. That is the definition. Then it is called as the function. That particular subset is called as the function. Function means every element in A has an image in B. It can have same image, a unique image. It cannot have two images. For example, 1, 2, 3, A, B, C. 1 is mapped to A, 2 is mapped to C, 3 is mapped to B. It's a function. Valid function. Because all the elements of A are mapped to a unique element in B. Now, let us take another example. 1, 2, 3, same A, B, C. 1 is mapped to A, 2 is mapped to B, 3 is mapped to C. All the elements in A are mapped to unique element in B. That means this is a function, valid function. Let us say another. In B, one element can have two inputs, but in A, one input cannot have two outputs. This is input, this is output in computer language. This is input, this is output in computer language. Now here A, 1, 2, 3, and here it is A, B, C. One is A and one is B, 2 is A and 3 is C. That means a single input in A, that this is not the function. The reason being, the input 1 has two outputs, A and B. A single input in A cannot have two outputs, but two inputs can have a same output. But one input cannot have two different outputs. In normal language, two multiple inputs, rather, instead of two, we will call it as multiple. Multiple inputs can have same output, but single input cannot have different outputs. Single input cannot have different outputs. This is not a function because one has two outputs. When relation is A to B, relation is defined as A to B. This relation A to B is not a function. This particular relation is not a function, but it's a valid relation, but it's not a function. And all the inputs, all the elements in input, this we will call it as input, let us say. In our modern language, we will call this as output. All the elements in input set should have a unique output. For example, the same we will take 1, 2, 3, A, B, C. 1 has A, 3 has B. But 2 does not have any output in B. Then it is not a function, because all elements in A does not have image in B as image for 2 in A is absent in B. Hence it's a valid relation, but there is no function. It's not a function. Here we can even say every element also. Instead of all elements, we can even say every element. Because it's only a language jargon, the concept is that all elements in A, each and every element in A should have an image in B. Then only it is called as a function. Now, example, if A is equal to 1, 2 and B is equal to 1, 2, then A cross B has how many elements? 2 to the power of mn. This is m is equal to 2 here, the cardinality of A. The cardinality of B is n is equal to 2, number of elements. Cardinality is nothing but number of elements in A, number of elements in B. 2 to the power of mn, 2 to the power of 2 into 2, that is 2 to the power of 4, that is equal to 16. Then, number of functions, these are subsets of A cross B, that is equal to relations A cross B, A to B relations. Subsets of A cross B are nothing but relations between A and B. A number of functions is equal to n to the power of m, that is equal to 2 to the power of 2, that is equal to 4. That means every element of the pair A cross B need not be a function. It can be a relation. But all functions are relations. That you please remember. All relations need not be functions, but all functions are relations. This I have explained in my other lecture, which I will be putting it as addendum, that I will be bringing it back from my mathematics by IITIAN lectures group to this playlist. I will be attaching that lecture in the playlist. Please refer to that lecture also. Please see that. Now, we understood what is a function now. Functions can be real valued functions. What is a real valued function? What is a number system? A real line will have minus infinity to plus infinity real values, and it will have natural numbers, integers, positive integers, negative integers, rational numbers, irrational numbers, and everything including it is a real line. Real valued functions means the value of the function is defined on the real line. Then they are called as the real valued functions. Then if it is not defined in the real line, what is the example? That's also there. When a number like square root of minus 1, it is not a real number. It is an imaginary number. Imaginary number. It's not on the real line. Then it's not the function which is going to give you imaginary number, that is not a real valued function. It's a complex number. It is imaginary. It is real. Real numbers will be on a single line, whereas imaginary numbers require a complex plane. Like in vectors, which I have explained, even complex numbers videos are also there in the other playlist. Those also you can see. Complex numbers I have explained in detail. And there is a number called P. with coordinates, let me say x1 and y1, then complex number z is equal to x1 plus I into y1. This is how a complex number is represented. And this particular value from origin to P is like your position vector, where I have explained very well in complex numbers video and also in the vectors video. This OP is equal to Z. Modulus of Z is equal to OP. Modulus of OP is equal to square root of x square plus y square. When a function yields real values, then that function is real valued function. When it is not associated with the complex plane, then logarithmic functions, why I am going little bit fast, the reason being, these are all the basic things which you have learnt in your elementary mathematics, elementary algebra, which need not be elaborated and expanded here. When it comes to drawing the graphs, I will explain separately. When I take up logarithmic functions separately, in this lecture I will be talking about the polynomial function. And the problem related to us, which I have taken it as an example, polynomial function. When I take up each and every, it is an introductory class, first class, mainly on functions. When I take up individual functions, I will be taking up individually about these real valued functions separately, logarithmic functions, and then exponential functions. When I take them up, I will definitely in detail, I will take the examples on them, and I will definitely ensure that you will understand the logarithmic functions in detail. I will clear the concepts of it. What is logarithm? There are different types of logarithms: natural logarithm, logarithm to the base 10. We will take a general logarithm, logarithm a to the base b, let us say, is equal to c. Then, just to see the magic, it goes to here, and log you want to solve for, to see that log is gone or log is removed from this equation, it implies a is equal to b to the power of c. When a is equal to b to the power of c, then when logarithm is taken, this implies, by taking logs on both sides, log a is equal to c into log b. Do you agree? If the same base is used, let me say e, if the same base is used, you just see, I have changed the base. Here b is the base, now I have changed the base. Now I have taken the logarithm of this equation. Then it implies, you just see, c is equal to log a to the base e divided by log b to the base e. This is one property. You should understand. And if natural logarithm, it is usually called as ln. ln a means ln a is equal to c means a is equal to e to the power of c. That implies, similarly, by taking log on both sides, you just see ln A is equal to C into ln E to the base E. This is also base E. When I take same base on both sides. What is the value of logarithm E to the base E is equal to 1? These are all the things which you have studied in your previous elementary mathematics classes. That means a logarithm value to the same base is equal to 1. ln log A to the base A is equal to 1. Please remember this. These are all about logarithm functions. I am only giving the brief what I am going to touch in functions in next classes. I will not be going in deep in this because I will be solving that particular question which I have given problem with the concepts of polynomial functions. This is. Next is exponential function. When I take up the exponential functions separately, at that time I will be discussing in detail. Exponential E, I have told you ln A to the base E is equal to B. It implies A is equal to E to the power of B. What is the value of E? E to the power of 1 is equal to 2.718 approximately. This is the value of E. Any function dealing with e to the power of x, that is an exponential function. This can be function x can be e to the power of gx. Some other function of x. Gx can be trigonometric function, gx can be another exponential function, gx can be another logarithmic function. For example, function x can be, try to understand these basics. Gx is sine square x into ln x to the power of 0.5. That can be gx. And function x can be something into gx, some constant a into gx, some another function hx into gx. Function x can be involving exponentials, some hx into e to the power of gx. Please see the beauty with the functions. Now, we will be taking up trigonometric functions also. We will be solving that question which is given in the first slide. Sin x, cos x, tan x, tan 2x, tan mx, cot mx, nx, sin nx. All these are trigonometric functions. Trigonometric inverse trigonometric functions. Psi sin inverse x, cos inverse x, all these are inverse trigonometric functions. Then hyperbolic functions. So let us discuss about the polynomial function. What is a polynomial function? A polynomial, if it can be expressed as a0 plus a1 into x to the power of 1 plus a2 into x to the power of 2 plus a3 into x to the power of 3 up to an into x to the power of n. Here a0 to an are arbitrary constants, don't worry about them. And the exponents are from 0 to n. a0 is nothing but a0 into 1, that is equal to a0 into x to the power of 0. That means non-negative integers. When n is equal to varying from 0 to n. And they are non-negative integers. Here, for example, in a polynomial equation, if n is equal to 0, note, if n is equal to 0, it implies function x. Let's say it is px, it can be function x also. N is equal to 0 in function x, that will be function x is equal to a0 into x to the power of 0, that is equal to a0, because other values will not be there, because n is equal to 0, only one value is there, then this value is a constant. This is called as constant function. Now, if n is equal to 1, it implies function x is equal to a0 plus a1x. Please see this. Other members will not be existing because x square x cube is not there. This implies linear function. It's a polynomial function only. It is a linear function. It is a straight line. Function x is equal to a0 is a constant function. Parallel to x-axis. For any value of x, function x is constant. Function x is equal to a0 plus a1x, that is a straight line with slope a1 and intercept a0. Let us try to draw this. Usually, function x is denoted by y-axis, on y-axis. This is x, this is function x, y-axis is function x. Then, function x is constant for all values of x. That means, here if it is function x is a0, then it is constant for all values of x. This is called as constant function. Now, another example what we have taken, function x is equal to a naught plus a1x. In this case, function x value is dependent on x, and at the same time it has an intercept. For example, if x is equal to 0 at origin, at x is equal to 0 on x-axis, then function x will be a naught plus a1 into 0, that is equal to a naught. That a naught is equal to intercept, it is called as and a1 is called as the slope of the straight line. This particular function x is equal to some constant plus some constant into x, a naught plus a1x. This is nothing but is in the form y is equal to mx plus c, where y is the function x, m is a1 and c is the a naught. Now let us draw it. Graphically how we represent it? We will go with graphs, learn with graphs. This is function x, and when x is equal to 0, this is origin. When x is equal to 0, function x is equal to a naught. And when x is equal to 1, function 1 is equal to a naught plus a1. When x is equal to 2, function 2 is equal to a naught plus 2a1. Function 3 is equal to, we are putting x as 3, a naught plus 3a. Now, this is a naught when function x is equal to here, some a1 we can say. This is a1. A naught plus a1. The difference we will call it as a1. And when x is equal to, this is x is equal to 1. When x is equal to 2 here, this is going on like this. This will be, let me say, this difference is 2a1 and total is a naught plus 2a. This is a straight line with a slope. It is a straight line. This is a straight line with a slope as a1. What is slope? Because we are solving the problem of polynomial, we will discuss polynomial little bit more in this class. How to find out slope? Slope is nothing but function x2 minus function x1 divided by function, not function, x2 minus x1 for a straight line. What is function x2 here? Function x2, that is function 2, is a0 plus 2a. Minus function x1, that is function 1, a0 plus a. a0 plus a1, sorry, a0 plus 2a1 divided by x2. This is a very important formula. Please remember this. This will be useful in calculus. As we move along, how to find out the middle point, how to find out the point with m:n ratio. This will be useful in geometry also. x2 minus x1. What is x2? x2 is 2 and x1 is 1. That is 2 minus 1. That implies slope is equal to a0 plus 2a1, a0 plus 2a1 minus a0 minus a1 whole divided by 2 minus 1. That is equal to a0 a0 get cancelled. 2a1 minus a1 is a1 by 1, that is equal to a. In the equation, function x is equal to a0 plus a1x. a1 is equal to slope. That as we have found out in the previous calculation. This equation, slope is equal to, for a straight line, function x2 minus function x1. This x2, x1 are arbitrary numbers. Anywhere you can take. For a particular straight line, the slope will be constant. The slope is not constant for a particular straight line, it will be a combination of straight lines. Please try to understand this concept. If some straight line is like this, and another straight line is like this, another straight line is like this, means this is having a slope of m1, this is having a slope of m2, this is having a slope of m3. All the three straight lines are different. You please try to understand. This equation will have function x differently. This will have gx differently, another function. This can have another function as hx. That means each straight line, when a particular straight line is there, its slope is constant. Slope cannot vary on the basis of x. Slope will be constant. When x is equal to 0, that will be intercept. Like this. This is like this. Straight line. This is mx plus c. That is equal to y, that is equal to function x. This is x. This is function x. Or we can even call it as y. Then, this m is constant. It cannot vary. Whether you take the negative values of x and y, or you take the positive values of x and y, either you take these two values or these values, this value, this value, this value, this is intercept, and this is this slope. This is this slope. Take any 2 points. Slope is equal to, take any 2 points, arbitrary points, function x2 minus function x1 whole divided by x2 minus x1. This is equal to slope. Slope of a function. Slope of a straight line. A polynomial having n as 0 in the polynomial equation, that is called as a constant function. When it has n is equal to 1, it is called as a straight line function. And a function, straight line function, for example, why I am stressing on graphs? The reason being, graphs are more required for understanding calculus well. This is function x, and if the straight line is this way, let me say, parallel to x-axis, y is not changing. It's a constant function. Please remember. In straight line, function x is equal to a naught plus a1x. Here a1 is equal to 0. That means slope is 0 for a parallel line to x-axis. One is parallel straight line to x-axis has a slope of 0. Why it is? The formula is function x is equal to, slope is equal to function x2 minus function x1 by x2 minus x1. Let me say x1 is 1, x2 is 2. Function x2 is same value only, because it is, let me say, a naught. This here also it is a naught. That means function x2 is also a naught, function x1 is also a naught. A naught minus a naught divided by x2 minus x1 is 2 minus 1. That is equal to 0 by 1. That is equal to 0. Any straight line parallel to x-axis has a slope 0. Next. These things will be useful in your geometry also. We learn calculus along with geometry. You will appreciate what is calculus then. Function x. Any line is there here parallel to y-axis. This x is equal to 1, let me say. This is function x1, this is function x2, but x1 is equal to 1, x2 is equal to 1, because x is not changing. Then in that case, what is the slope? Slope is equal to, why I am repeating the formula? The reason being, it will be imprinted in your mind. The formula is function x2 minus function x1 divided by x2 minus x1. Function x2 value is different. Let me say it is a1, it is a2, it is a2, it is a1. Then a2 minus a1 divided by 1 minus 1. That is equal to some value a2 minus a1 divided by 0. That is equal to infinity. Something divided by 0 is infinity. That means the slope of a straight line parallel to y-axis or perpendicular to x-axis is infinity. Slope of straight line parallel to y-axis, or it is perpendicular to x-axis, is equal to infinity. Now, let us see another function. There is a function, this is function x, this is x. There is a function x is equal to x. Let function x is equal to x. Then what will be its slope? What will be its slope? That means function x1 is equal to x1, function x2 is equal to x2, because function x is equal to x. Here it is x1, here it is x2, and here it will be function x1 that is equal to x1, and here it will be function x2 that is equal to x2. What will be its slope? Slope is equal to function x2 minus function x1 by x2 minus x1. Function x2 is x2 minus x1 divided by x2 minus x1. Both are same, then it will be 1. The slope, this particular equation is called as y is equal to x, or function x is equal to x. Its slope is equal to 1. Any straight line whose slope is equal to 1 will have function x is equal to x as the function, y is equal to x as the function. And the angle theta, here I am telling you, going little bit of trigonometry, tan theta is equal to 1 when theta is equal to 45 degree. That means here angle will be 45 degrees measured from the, please understand, measured from the positive x-axis. Theta is equal to 45 degrees. Then slope is equal to 1, and the equation will be y is equal to x, or function x is equal to x. These are the different functions, and another polynomial function will be ax square plus bx plus c. Function x is equal to, it's a square function having power 2, and it will be a curve. It cannot be a straight line. We have seen straight lines parallel to x-axis, straight line parallel to y-axis, and straight lines inclined to x and y-axis with angle 45 degrees, and straight lines having a specific slope with intercepts. These are all linear equations, and this is an equation with power 2. Square. And another function can also be there, that can be cubic. Ax cube plus bx square plus cx plus d. Another can be function x is equal to ax to the power of 4 plus bx to the power of 3 plus cx to the power of dx plus e. Don't worry about a, b, c, d, e values. They can be 0, they can be negative, they can be positive, they can be anything. These are all arbitrary constants. Function x. Now, these are all polynomial. These polynomial curves we will be detailing in the next class. And when we continue with the functions, I will be continue with the polynomials for 1 or 2 more lectures. Then only we will be moving to other lectures of logarithmic functions, exponential functions, and other functions. And one good example I have made for the benefit of all, we will solve that problem. It is a little bit tricky and important problem, and you may feel little bit an advanced level problem, but still it is easy to understand it with the concepts whatever we have till now, and it is easy to absorb the concepts also. Another one more important formula I have forgotten to tell you, that is function x is equal to ax plus b. Function not function, gx is equal to cx plus d. Then what is the function of gx? F of gx, it is called as f of gx. When there is a f of gx, then this in function x, whatever x is there, that will be replaced by gx. Are you able to follow? F of gx is f of, it is called as of. F of gx is where x in the function x is replaced by gx. Similarly, g of function x. This also will be detailing. Don't worry in the next class, because this class is becoming very lengthy otherwise. G of function x. Because we have to solve that problem also. That's a little bit lengthy problem, but a simple problem only. G of fx is equal to GOF. It is fog, it is GOF. That means in gx, this x is nothing but function x. Now, let us see what is fog and what is g of x. Let me see, let me write here. Please try to understand this concept, very important concept. F of gx is equal to f of, what is gx? Cx plus d. Are you able to follow? Gx is cx plus d. This whole is x here. This whole x is there in function x, that will be replaced by cx plus d. Now, what is function x? Ax plus b. A into this x is replaced by cx plus d. Plus b. That implies f of gx is equal to acx plus ad plus b. That is equal to acx plus ad plus b. Now, let us see what is g of x. G of that is fog, fog x, gof. That is equal to g of, what is function x? Ax plus b. Wherever x is there, that will replace in g as ax plus b. That is c into ax plus b plus d. That implies gof x is equal to g of function x is equal to ACX plus BC plus D. That is equal to ACX plus BC plus D. That means f of gx need not be equal to g of fx. I am writing it as need not be. There may be some functions where fog x is equal to gof x. Fog x, here in this particular example, fog x is not equal to gof x in this particular example. For example, another thing, my function x is equal to ax plus b. Then what will be the value of function x minus 5? Wherever x is there in function x, I will replace this with x minus 5. That means a into x minus 5 plus b. That is ax minus 5a plus b. That is equal to ax plus b minus 5a. Here, let us take any other functions like function x is equal to a into x to the power of n, let us say. Then function x minus 5 will be, this x will be replaced by x minus 5, that will be a into x minus 5 to the power of n. This implies, please try to listen it carefully and understand it. Shifting x value in function x a into x to the power of n will not change the coefficient of x to the power of n. That means function x is equal to a into x to the power of n implies coefficient of x to the power of n is equal to a. For function x, a into x minus p to the power of n also implies coefficient of x to the power of n is equal to a only. Example, function x is equal to ax square. That implies function, it is x minus p. Here what we have to write, function x minus p. Function x is equal to a into x square. Function x minus p is equal to a into x minus p whole square. That is equal to a into x square minus 2px plus p square. That is equal to ax square minus a into 2px plus ap square. The coefficient of x square is a only here also. Here also the coefficient of x square is a only. That means if function x is equal to a into x to the power of n, or for function of x minus p is equal to a into x minus p to the power of n, have same coefficient for x to the power of n. That means shifting of x value in a into x to the power of n function x will not change the coefficient of x to the power of n in a into x minus p to the power of n. If the x value is shifted by minus p, it can be p can be negative, positive, and it's an arbitrary constant. This is a very, very important concept which you have to remember, so that on this concept there can be questions. Some question is asked in JEE Advanced 2025 on this concept. Using this concept, we will be able to easily find out the coefficient of some x to the power of n. Now, without making further, what is function x minus 7? Function x minus 7 is equal to ABCD. We will substitute a into a is 1. 1 into x is x minus 7 plus b is 2. 2 into x minus 7 whole square plus 3 into x minus 7 whole cube plus 4 into x minus 7 to the power of 4. Now, g of x minus 5, that is 2 into x minus 5 plus 3 into x minus 5 whole square plus 4 into x minus 5 whole cube plus 5 into x minus 5 to the power of 4. This is what is when you substitute the values of A, B, C, D, P, Q, R, S. Now, the value of x to the power of 4, the coefficient. For example, let us call for this. X to the power of 4 is there in this only. Therefore, the coefficient of x to the power of 4 in function x minus 7 is equal to 4. Because the coefficient of x is 1. Other x's are nothing but x to the power of 1, x square and x cube. That means one value we have got as coefficient of x to the power of 4 in function x minus 7 is equal to 4 in this. Now, for x minus 5 we have to find out. We know f function x minus 7, g x minus 5. Therefore, for x minus 5 is equal to function of g x minus 5. What is g x minus 5? G x minus 5 we have already have the value. Then what will be the function of gx minus 5? That will be function of 2 into x minus 5 plus 3 into x minus 5 whole square plus 4 into x minus 5 whole cube plus 5 into x minus 5 to the power of. This whole will be x in this function. What is function x? 1 into x. What is the x value here? 2 into x minus 5 plus 3 into x minus 5 whole square plus 4 into x minus 5 whole cube plus 5 into x minus 5 to the power of 5. We are writing function of gx minus 5. It is gx minus 5. Function of gx minus 5 we are writing. This is equal to plus 2 into x square. That is 2 into x minus 5 plus 3 into x minus 5 whole square plus 4 into x minus 5 whole cube plus 5 into x minus 5 to the power of 4 whole square. Plus 3 into 2 into x minus 5 plus 3 into x minus 5 whole square plus 4 into x minus 5 whole cube plus 5 into 4 x minus 5 to the power of 4 whole cube plus 4 into 2 into x minus 5 plus 3 into x minus 5 whole square plus 4 into x minus 5 whole cube plus 5 into x minus 5 to the power of 4 whole to the power of 4. This is the value of log x minus. The whole is the value of log x minus. It's a very big equation, very big equation, and for solving it, it takes much of the time, and we have to find out the x to the power of 4 coefficient here. When you see, let us try to do something here. When you see here, 1 into this line, when you see, x minus 5 to the power of 4 only has got the x to the power of 4 value, coefficient. Coefficients of x to the power of 4 implies 5 into 1. First one is 5 into 1 plus second one. This whole square, x minus 5 to the power of 4, again that to whole square. X minus 5 whole cube, again to square. And this also. This also. This is a very big example. And as far as the first one is concerned, in hx, 21 into fx minus 7, 21, that is 21 into fx minus 7 is equal to 21 into 4. That is equal to 8. Part of the equation we could find out, and other part is very large. You try to find out, expand them, you will get the exposure, and also you will get the practice for finding the x to the power of 4 value, and it is square here, it is cube here to the power of 4. This type of practice problems, once you make practice and try to solve it and understand the concept, you will be able to easily do the problems that are given in the examination if the type of concepts being used on the basis of these concepts only if the questions are given. It is here, I am here to make you understand the concepts. The first we have got the value as 84 and second value is a very big value because to the power of 4 we have to find out, the cube you have to find out, and also let me try this second part. Second, let us this is 1 and let us do the second. 2 into 2 into 2 into x minus 5 plus 3 into x minus 5 whole square plus 4 into x minus 5 whole cube plus 5 into x minus 5 to the power of 4 whole square. Then this will be equal to, please do it carefully, 2 into 2x minus 5, 2x minus 10 plus 3x square minus 30x plus, don't worry for small errors, you understand the concept, plus 3 into 25 is 75 plus 4 into x cube minus 3 a square b. That means 3 into x square into 5, 15 minus 60 x square plus 3 ab square. A is 1, 3x into square is 75. 75 into 4 is 150. 75 into 4 is 300. 300 x minus 4 into 5 into 5 is 125. 125 into 5 is 625. 625 into 4 is 2500 plus 5 into you just see how long it is, but I have given it deliberately so that you will understand the concept. Concept is more important rather than the particular answer, and we have to use the binomial theorem here. You can use the binomial theorem for all this and you can find out 5 into x to the power of 4 minus 100 into x cube plus 750 into x square minus 2500 into x plus 312. 5, 5 is 25, 125, 625, 625. This whole square. That means 2 into all x's on one side, on all x squares will write in the ascending order. Minus 10 plus 75, 65, 65 minus 2500, or we can start from x cube, x to the power of 4. Otherwise, 5 into x to the power of 4 minus 100 into x cube plus 4 into x cube. That is minus 96 x cube. What are the x squares? 750 minus 60 is 690. 690 plus 693 x square. Then what are the x's? Minus 2500x plus 300 to minus 2200. Minus 2200 minus 2230 minus 2230 plus 2 minus 2228x minus 10 plus 65 plus 65 minus plus 65 plus 3125 is 3190. 3190 minus 21 2500 14. This holds. We just see how much it is. We can say M N O P Q. That means M plus N plus O plus P plus Q square. Once you do this, you will get the x to the power of 4 coefficient. Similarly, for the cube, another equation is there, third equation, and fourth. These 4 equations, if you do, you will get an answer. It is a question made by me out of my intuition. I have just given simple values of x to the power of 4 plus and all those A, B, C, D as 1, 2, 3, 4 and P, Q, R, S as 2, 3, 4, 5. But the problem turned out to be a very big problem, and good or bad, it's going to give you a large scope of learning. Ultimately, instead of A plus B plus C whole squared, whole cube, whole to the power of 4, it is giving A plus B plus C plus D plus E. That means ultimately we will be learning A plus B plus C plus D plus E to the power of 1, A plus B plus C plus D plus E whole square, A plus B plus C plus D plus E whole cube, A plus B plus C plus D plus E to the power of 4, A plus B plus C plus D plus E to the power of 5. And this requires lot of energy, lot of time, and lot of concentration, and lot of concepts to be understood and solved. And the final value I will be giving. The final answer is for this for x minus 5, for x minus 5, x to the power of 4 coefficient is equal to 7020 4653 46543 894277. Ultimately, what we wanted is hx, x to the power of 4 coefficient in hx. That is equal to 21 into function x minus 7 minus 32 into fog x minus 5. That is equal to 21 into 4 minus 32 into. I am only talking about the x to the power of 4 coefficient. 702046543894 is equal to minus 22465 489 404 616 780. This is the answer. You just see from a simple function of a simple function ax to the power of 4 plus bx cube plus cx square plus dx or ax plus bx square plus cx cube plus d. From a simple function of fx, ax plus bx square plus cx cube plus dx to the power of 4 and gx px plus qx square plus rx cube plus sx to the power of 4, where a, b, c, d are 1, 2, 3, 4 and p, q, r, s are very simple values, not complicated. 2, 3, 4, 5 only for integers. When you check up fog, the values are extraordinarily large. That means you should understand a function of a gx. To tell the importance of function of gx and g of x, I took up this example so that you will appreciate it. Function of g x minus 5 is that. Now you tell me if x hx is equal to, it will be a function of x minus 7 only, 21, minus 32 into g of x, g of x, sorry, g of x minus 5. What its value will be? This value will be entirely different from the value what we have got previously. This is the real beauty of mathematics. That means every step and every symbol and every each and every meaning out of that symbol will give a different value. So that we can address many numerous functions, the values. I have given function x, the simple one, function x minus 7 into graph x minus 5. It can be sin x, cos x, tan x. Imagine. That means there is a vast possibility of application of functions in mathematics, and indirectly mathematics applications will go into physics, sciences, and into chemistry. These applications in the sciences will definitely open doors for the numerous huge opportunities for solving different types of problems, especially in data sciences, electronic engineering, electrical engineering, and also in computer science. this type of use data, use values, and they'll be useful even for application, what you call space applications also. Functions will be big functions. These are all small functions I have told you. I have made you to understand the what you call the result. It's not about the result what you are going to get it and how you are going to solve the problem. This type of problem is given in IIT JEE Advanced in 2025 with a simple values so that if you have done this and understood these concepts, that particular IIT JEE Advanced problem you might be doing in a minute or two. Please apply these concepts and in this type of problems apply the concepts like this and try to get the answers and you get the correct answers if you work hard and definitely try to improve your concepts like this and practice tougher problems so that if easier problems do come in the examination, you will be able to do easily. Thank you for listening to me. Thank you for seeing my lecture. Best of luck to all of you. And next lecture will be on this polynomials only. And I'll be going for graphing of this function. I'll be going for graphing of this function. For different x values, how the graph looks like. Let us graph it. Let us plot it. And let's do it. Simple. These are all simple. It's only a mechanical application. Just to get the concept, apply the concept, you get the answer. Whatever big or whatever small or negative or positive or infinite or not infinite, minus infinite, zero or whatever the value. Don't worry about the value. Please make your concepts clear, apply the concepts correctly, you will get the answer correct. Best of luck to you. If there is a value addition because of this lecture to you, kindly share this video to all, to the known persons, type this video and share my subscribe, share my channel details and subscribe to channel Maths and Science by IITIAN.